How can you satisfy your hunger with just a 5 peso coin inside your pocket? It might seem challenging, but it's indeed possible if you opt for a delicious and affordable food like the bread. We cannot deny the fact that bread is our go-to food when we're hungry, especially when we're on a tight budget. Yet, why does bread have the ability to make us feel full, even though it's essentially just made of dough?
Well, hold on to your hats because we're about to reveal the magic behind bread. It's not just flour and water, it's a masterpiece in the making. The secret? A captivating process known as the redox reaction. Yes, it's science, it's art, and it's what makes your daily bread nothing short of extraordinary. Get ready for a revelation that will transform this simple yet satisfying food and uncover the mysteries in the bread making.
Macroscopic representation of the redox reaction that occurs between yeast and sugar. Glucose is oxidized, and yeast cells use it as a source of energy. The carbon atoms in glucose are going from a more reduced state to a more oxidized state. This oxidation reaction involves the removal of electrons from glucose molecules. The electrons removed from the glucose are transferred to other molecules within the yeast cells. This reduction process is essential for the yeast to generate energy. The yeast cells grow, the gluten-protein pieces stick together to form networks, and alcohol and carbon dioxide are formed from the breakdown of carbohydrates that are found naturally in the flour. Yeast uses sugars by breaking them down into carbon dioxide and water. The yeast needs lots of oxygen in order to complete this type of fermentation. In a bread dough, oxygen supply is limited and the yeast can only achieve partial fermentation. And instead of carbon dioxide and water being given off, carbon dioxide and alcohol are produced. This is called alcoholic fermentation.
The carbon dioxide produced in these reactions causes the dough to rise, and the alcohol produced mostly evaporates from the dough during the baking process. During fermentation, each yeast cell forms a center around which carbon dioxide bubbles form. Thousands of tiny bubbles, each surrounded by a thin film of gluten, form cells inside the dough piece. The increase in dough size occurs as these cells fill with gas. The fermentation of glucose by yeast into ethanol and carbon dioxide involves a series of chemical reactions at the microscopic level. Glucose is a 6-carbon sugar molecule. At the microscopic level, glucose molecules are composed of 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Yeast is a microorganism consisting of individual yeast cells. These cells contain enzymes, particularly zymase, that catalyze the fermentation process. Yeast cells interact with glucose molecules. Through enzymatic reactions, yeast cells metabolize glucose. During the fermentation process, glucose molecules are broken down into 2 molecules of ethanol and 2 molecules of carbon dioxide. Ethanol is produced and is consist of 2 carbon atoms, 6 hydrogen atoms, and 1 oxygen atom. The ethanol produced by the yeast cells remains within the cells and is not typically a significant component of the final bread, as it mostly evaporates during baking due to its low boiling point. As a result of the enzymatic reactions, carbon atoms from glucose combine with oxygen atoms to form 2 molecules of carbon dioxide. The carbon dioxide gas produced within the yeast cells is released into the dough. This gas gets trapped within the gluten structure of the dough, causing it to expand and rise. Glucose in this reaction is oxidized. During this process, glucose loses electrons and becomes more positively charged, and it is broken down into carbon dioxide and ethanol, whereas the yeast reduces the glucose. In this process, the yeast gains the electrons that were originally part of the glucose molecule, and this reduction step is what allows the yeast to grow and produce carbon dioxide and ethanol as byproducts. This is the complete balanced equation. C6H12O6 represents glucose, a sugar found in the dough. 2C2H5OH represents 2 molecules of ethanol, which is one of the byproducts of yeast fermentation. 2CO2 represents two molecules of carbon dioxide, which is responsible for the leavening or rising of the dough. Redox reactions are critically important in the food industry, particularly in baking bread, where they drive essential processes. Redox reactions in bread making are fundamental to leavening and development of desirable taste and texture, making them indispensable for producing high-quality bread products.
In every slice of bread, there is a story of electrons transferring, of molecules transforming, reminding us of the wonders of the natural world. Understanding redox reactions isn't just about flour and yeast. It's about comprehending the essence of life itself. So, the next time you enjoy a warm slice of bread, remember the fascinating chemistry that made it possible.